In this lecture, we're going to discuss how to use the core Angular HTTP API. And by the end of this lecture, you're going to know how to set up your application so we can inject and use the HTTP client library. You're going to know how to send the various different types of HTTP requests. You're going to know how to send custom headers with your requests. And you're also going to learn how to handle errors. Now, to demonstrate our functionality, I've created a simple application. We only have one component, the app component, the root component. And inside there, I'm just rendering a bunch of buttons. Each button has a click handler and it's calling the associated function on the component. And each of these functions are just, they're not doing anything right now other than logging something to the console. So if I was to run this, you'd see the application on the right-hand side. It's just a bunch of buttons. Now, the HTTP client library in Angular is a service that we inject into our classes. So I'm going to inject it into the app component constructor. So I'm going to add it as a local variable, local property called HTTP, and the name of the service is capital H, lowercase TTP. Now, in order to use it, we need to import it. So let's go to the top of the file. And we import HTTP, and it lives in Angular/HTTP. We're going to need a number of other classes from the HTTP module, so we might as well import them all now. But importing these classes, and especially just the HTTP class, isn't enough. Like all things you can inject, we must configure these classes via a provider in the DI framework. And since we want to use the HTTP client library everywhere throughout our application, we're going to configure it on the root ng module. Now, before you get too excited, the provider configuration for HTTP isn't actually so straightforward. To actually provide HTTP, we need to provide just a number of different classes and providers that work in conjunction together. So to simplify this entire process, the Angular team has given us a handy way to configure our ng module with all the required providers for HTTP. We simply import something called the HTTP module and add it to the imports list of our ng module. If I scroll to the top, we import HTTP module from Angular HTTP, and we add it to the imports property, not the providers property, but the imports property. And then we delete providers. We don't need to explicitly provide HTTP anymore. Now, if we actually take a look at HTTP module, we can perhaps get a better idea of what's going on. So if we look at the code for HTTP module, we can see all that this is another Angular module, and all this module has is a providers property, and inside here it's providing just a number of different things that are needed in order to enable HTTP to work. Now, you could, if you wanted to, just copy and paste this into your providers, but all we need to do is import the HTTP module, add it to our ng module import, and this provides all of this for us. So importing HTTP module into our ng module configures our ng module's injector with all the providers needed in order to use HTTP in our application. So to demonstrate the HTTP client library, we need a test API that we can use. One such API is the HTTP bin.org API, and this has a number of API endpoints which we can use to test different HTTP actions. So if we perform a get to the get endpoint, this is the data that will be returned. It will return a JSON object, and actually the JSON object it's returning is just information about our request mirrored back. And going back into our Plunker, we're going to store the API root on a string on our component so we don't have to repeat this domain for every API request. We've injected our HTTP client library. Now in the HTTP protocol, we have a set of verbs for each URL. So for a given URL, we can perform a get, a put, a post, a delete, a head, and an options request. And to mirror those, I've created a button for get, post, put, and delete. So I'm going to demonstrate each of those verbs just by fleshing out the function associated with each of those buttons. Let's start with the get button. So that get button calls the doGet function. So to perform a get request, we simply call the get function on our HTTP client library. And this get function returns an observable, which for now we're just going to subscribe to and print the response to the console. Now the first thing I need a URL that I'm going to send the request to. And the URL for a GET request is the API root /get. Then I call this .http.get. I pass in the URL. This returns an observable. So to subscribe to the result of the observable, we call .subscribe. And in the callback, we're passed a response. And to get the body of the response, we call res.text. And that's what I'm printing to the console. So now if I open up the console, let's get some extra space, clear it, rerun the application, and now I'm going to issue the doGet request. Let me get some more space. So now we're seeing an actual response being printed to the console. Now the server, the http bin.org server, returns JSON. And although it might look like we are printing out an object, we are in fact printing out a JSON formatted string. So to convert the JSON formatted string into an object, we just call res.json instead of res.text. Rerun the application, clear the console, issue get again. And you can see in the console we're now rendering out an object and not a JSON formatted string. Okay, that's how we can do a basic GET request. We can also pass to the GET function a set of optional query parameters as the second argument. Now we can just pass as that second parameter something that looks like an object. But to help in creating our query parameters object, we can use a helper class called URL search params. Now we need to include that first in our imports. And then in the doGet function, I create a new instance of URL search params and I store it in a variable called search. And then I add individual query parameters by calling the set function on our search object. And then we pass an object as the second parameter, an object with a property of search. And we pass in our search object as the value of that property. But before I hit run, I just want to mention that we can take advantage of destructuring in ES6. So if you remember, if the key and value of an object are the same name, then we can shorten search:search to just search. So now if I rerun the application, let me clear the console. Let me open up the network, clear that one as well. And now when I hit get, if you look in the network tab, you can see that actually we're passing in /get foo is equal to moo and limit is equal to 25. We're passing in the query parameters as well. Okay, that's get. To perform a delete request, we just call the delete function. And the format of this function is exactly the same as the get function. And we can even pass in query parameters as well. So I'm just going to copy our code directly. I change the endpoint to /delete. And I change the function to delete as well. Now, if we rerun the application, let's clear the network tab. I then press delete. And you can see it's now sending a delete request. Now, an options request is just something the browser always sends before a delete, a put, or a post. It's just a separate request all browsers send just to make sure that the application is allowed to perform a put, a post, or a delete. And to perform a post request, we call the post function. Now, the format of the post function is similar to a get, but when we do a post, we usually want to pass in data as well. So the second parameter to post is not a set of query parameters, but instead an object which will be passed as the payload for the request. So I'm going to change the endpoint to post. I'm not going to bother with query parameters, but you actually could send query parameters as well. And as a second parameter, I'm going to send a payload, just some sample data. Mufu Gulu. And also remembering to change the function to post. So now if I rerun the application, I'm going to clear the network tab. I'm then going to click post. And you can see there, I'm sending a post request. And if I click into that request, that's the response. You have to see the header section to see what we actually sent. You scroll to the bottom, and there you can see the request payload is Gulu Mufu. And as I said, just like get, we can also send with query parameters. So if I add in those query parameters again, but now we just pass them as the third parameter. So now if I rerun the application, press post, you can see it's posting, but now it's posting to the URL, but with the query parameters appended to the URL. And to perform a put request, we just call the put function. It works in exactly the same way as the post function. Change the URL endpoint to put, and change the function to put. Now if I rerun the application, clear, press put, you can see now we're sending a put request. Now, if you prefer to work with promises over observables, it's actually quite easy to convert between the two. We just call toPromise on the observable that gets returned, and this will convert it into a promise instead. So let's work with the get function. I'm going to copy that. We have explicitly created a button called asPromise, so I'm going to copy that into that function, which is doGetAsPromise. And then instead of calling subscribe, I call toPromise. And since with promises we work with the then callback function, the then handler, we then change our subscribe to a then handler instead. But the toPromise function here, this is actually an observable operator. And if you remember, to use observable operators, we need to include them into our application. We need to import them into our file. So we can do that in one of two ways. We can either import all of the operators. If we go to the top, we can either import all of the operators in RxJS with just the import RxJS/Rx statement at the top. Now this will work, it's fine for development, but it will unnecessarily bloat the application. So I don't recommend it for production. Instead, what I recommend that you do is to individually add the operators that we need for our application. So to add the toPromise operator, we just import RxJS add operator toPromise. And now if we run our application, we should see no error in the console. Everything's fine. And if I call asPromise, this will now perform a GET request, but convert it to a promise and then print out the response in the console, which it has. So how do we handle errors? So we can simulate errors from our test server just by performing a GET request on a POST endpoint. So I'm going to take our getAsPromise function, the body of the code for this function. I'm going to copy and paste it into the getAsPromise error function. And then to simulate an error, instead of performing a get on the get endpoint, I'm going to change this to post. And this will make the server return an error. So with promises, we can either pass in a function as the second parameter to the then callback. So message.status will give us the status code, and then if there's some helpful text, it will print it out next to it. So now if we rerun our application, let me clear the console. Let me click error as promise. And there you can see we're now printing out an error message from our error handler. So 405 is the message status, and method not allowed is the status text. Now with promises, we can also handle errors just by adding a catch handler to our promise chain. And that's my preferred method. So we can .catch, and then we pass in a callback function. And now if we rerun our application, error as promise, we still get the error being handled and printed to the console. I just find that a catch function is just easier to see visually on the screen than scanning for a second parameter to a then function. Now, just as a helpful little hint, if you need a reminder about what all these different HTTP status codes are, you can go to the site httpstatuses.com. And for every one of these, you can click on a link. So we're getting 405 method not allowed. If we click the link, it just gives you some nice helpful information about what that error code really means. And if we wanted to handle that error as an observable, let's do the same thing here. Copy and paste it into our observable error function. We don't want to convert it to a promise. We just want to subscribe. And then we just handle it just the same way as we handled it in the first case of then. We'll just pass it as a second parameter. Whatever the second parameter to the subscribe function is, that is the error handler for an observable. So now if I rerun the application, clear the console, error as observable. There you go, we can see the error response getting printed to the console again, but this time it's getting printed from the second parameter to the subscribe function on an observable. So HTTP headers are bits of metadata which the browser attaches to your HTTP requests when it sends them to the server. So these can be things like your IP address, the type of browser you're using, and so on. These are all added to your headers in your request. And in fact, the test API we are using is echoing our request headers back to our browser. But some APIs require that we send some custom headers with our requests, and we can do that quite easily with the Angular HTTP client library. Now, to send headers with our request, we need to import two helper classes. So one of them is request options, and the other one is headers. We've already included those. So for our sample, let's send a basic authorization header. This is just a header called authorization with a value that is a username and password converted to base 64. Now there's no need to worry too much about the specifics, just understand that the built-in JavaScript function B2A will convert from a string to base64. So I'm going to start fleshing out our doGetWithHeaders function. First thing I do is I create an instance of headers by calling new headers. I then append to our headers a header name, which is authorization. And I'm just going to use the B2A function to convert username, password to base64. And then if I wanted to, I could also create some search parameters. Let me do that as well. And then now I want to create a request options object, like so. So let ops equal new request options. And then on this request options object, I'm going to add the optional parameters of our request. So one of them is the headers. So I can pass it in just like that. But then also I can add in our URL search parameters as well. So let me add those in. Then let me generate the API, the URL that we're going to hit, which is just a normal get URL. Then I'm going to call get on our HTTP client library, pass the URL as the first parameter, and then I'm going to pass in our request options. So if you remember previously, we were just passing in the search parameters as a shortcut like this. We can actually just pass in an object if we want to. But really, if we're starting to send in more complicated options, it's better to import the request options and create a request options object to pass in instead. So that's what we're doing here. Remember, for get, it's the second parameter, and for put post, it's the third parameter. And then I'm just going to call subscribe on the response. And now if I run the application, let's open the console, clear the console, clear the network, and then I'm going to press the with headers function. Here we go, let me scroll up. And you can see we're performing a get request. Let me scroll up a bit more. And if I scroll down, you can see that one of the headers that we're sending is the authorization header. This is the header that we created when we added this headers object here. So that's it for the core HTTP API. To summarize, we inject the HTTP client library into our classes. It's a dependency that needs to be configured in Angular's DI framework. But rather than set up each provider for all the parts of the HTTP client library separately, we can instead import and add HTTP module to our ng module imports list. This sets up the injector on our ng module with all the necessary providers needed to support making HTTP requests. We can then make requests for all of the different HTTP verbs by calling matching functions on our HTTP client library. By default, these requests return observables, which we can subscribe to. We can also convert these observables into promises if we so wish and handle the asynchronous responses that way. We can handle errors using the typical observable or promise error handlers. And we can send custom headers alongside our request by passing in an appropriately configured request options object. This lecture covered the basics of using the HTTP client library. In the next lecture, we'll go through a specific example using promises.